Alright, so we have a vector decomposition problem in which I want to write this vector f in terms of components in the e hat 1 direction and the e hat 2 direction as defined here. And the way that we do this, if you follow my recipe, we construct this vector triangle where the hypotenuse of the right triangle is the vector f itself, and then these other two sides, these are vectors which when they add them together I get f. So I'm going to arrange these other two vectors in tip to tail fashion so that they add up to that vector f. And these other two vectors are going to be parallel to the e hat 1 and e hat 2 direction. So here's this one component in the e hat 1 direction like so, and I've got this other component in the e hat 2 direction like so. And when we add those two pieces together we get the original f. And now the rest is trigonometry. What we have to do is figure out the lengths of these two vectors so that they add up to the f, right? And it's a matter of identifying an angle right here. So in this problem, I'm given that this sort of angled ramp right here, or this angled line right here, is at an angle of theta relative to the horizontal. So the e hat 1 direction is parallel to that line. So it must also be at an angle theta relative to that vector f. Aha, so this tells us it. So this component in the e hat 1 direction, there's the e hat 1 direction, it's got an f cosine theta because it's the side adjacent to the angle. Whereas the piece in the e hat 2 direction, it's an f sine theta because it's the side opposite of the angle in this right triangle, right? This angle right there is 90 degrees. So there's that. And then you got to be careful about the signs. This e hat 1 component, that's in the direction positive e hat 1. But the so right here there's a positive. And then the e hat 2 direction, notice that the e hat 2 direction points sort of down and to the left, whereas the e hat 2 component of this vector points down and to the left, whereas the e hat 2 basis vector points up and to the right. So this is actually in the minus e hat 2 direction, this component right here. So that's what we get, and that explains our solution. In fact, I'll go ahead and put a box around it, like so.